All right, so our review for our first summative in Algebra 2, there's two versions of every single question. I'm actually going to go over all of these in this video, and if you were in class, probably one of your teachers, me or Mrs. Meyer, we went over A's or B's, but not both, so keep that in mind. All right, we're going to be simplifying these expressions here on number 1. We're going to start by distributing the 4, so we get 4x plus 8, and then same thing here with the 6x, so plus 6x times x would be 6x squared, and then minus 30x. Please don't leave your answer there, though. We do have some like terms. I'm going to leave the 6x squared as the first term, but I will have to combine right here and here. So final answer for me would be 6x squared minus 26x when you combine, 6x when you combine those like terms, and then plus 8. Technically, you can write your answer in any order, but this is the order that I would write. It is called standard form. Example B is very similar, but this time we're going to distribute a negative 7. So our new problem is 12x minus 7x, and then minus 70 when you keep distributing that negative 7. Again, we're going to collect our like terms right here. So you have a 5x minus 70, and that's as far as we can go on that question. Box it in. Number 2. 2a specifically, you have a couple of things to distribute. I'm running out of vertical space here, so I'm going to go underneath and distribute the 3x here and here. And then watch out, you're distributing a negative 2x here and here. So next line is a 3x squared, x times x is x squared, minus 27x. And then be careful here, it's a negative 2x. So negative 2x squared minus 2x. Don't stop there though, you still have more like terms to collect. 3x squared minus 2x squared would be a 1x squared. And then we have a couple of x's. So negative 27x minus 2x would be a negative 29x. That is the final answer that I want to see on your problem. All right, continuing on with 2b, we're going to distribute, again I'm running out of room, so I'm going to distribute this negative 5 right here to the x plus 1. Uh-oh, pen's not working. There we go. So negative 5x is being negative 5 is being distributed here and here. So our new problem is 10 minus 4x, and then minus 5x. Be careful here, negative 5 times 1 would be a negative 5. Combining our like terms once again, combine these together, you get a negative 9x. And then 10 combined with a minus 5 would be a plus 5. So final answers, the order can change, the order can vary, but your terms and your signs all need to be the same. So still in this section, you're going to be asked to not only simplify algebraic expressions, but also evaluate them. So we're plugging in x equals 4 and y equals negative 7. So what I like to do is write down the skeleton and then place the numbers inside of the skeleton where they belong. So x equals 4, so this is a 4, and y equals negative 7, so this is a negative 7. From here, I literally just type this exact thing in my calculator. So negative 2 times 4 minus 5 times negative 7 squared. But I'm going to include those parentheses where you see them in the skeleton, and that's going to give me the right answer. I believe this one comes out to negative 253. Fingers crossed that I didn't mess that up. All right, this next question. Same idea, I'm going to write down the skeleton. So 4 times something squared plus 7 times something. There's a skeleton. Let's plug in a equals negative 5. And then b equals negative 3. Oh man, I'm having a lot of technology trouble today. Let's make sure this is working. All right, here we go, negative 3. So again, you are more than welcome to just type all of this in your calculator in one step. Make sure the negative 5 has parentheses around it before you square it. And I think I already did this one. Let's see, I got a 79. For these two questions, you got to be careful because there's what we call implied parentheses around the numerator and denominator. So not only do you have to put parentheses around the x's and the y's, which you really don't need a parenthesis here, but that's okay. You have to put a parenthesis set around the entire numerator and the entire denominator. So like here, I'm not going to write a parenthesis around the x. Well, I guess I could. All right, so x goes here plus 3 times y squared, and then close the denominator as well. So x equals negative 2, so this is a negative 2, and this is a negative 2. And then y equals negative 3, so this is a, positive 3, hello. So that's a positive 3, and this is a positive 3. So the very important critical moment here, guys, is either you need to simplify the numerator and denominator separately and then compute the division, Or if you want to do this in one step, that's fine, but you have to remember to put big parentheses around the entire numerator and the entire denominator. So when you type that in your calculator and then you bring it back to a fraction, hitting Math Enter Enter, you should get 29 over 25. Now here's our first typo. I'm sure it won't be our last. This is supposed to say A and B, not X and Y. My bad. So same idea. We have parentheses around our entire numerator. So here's the skeleton. A squared minus 5 times B. Close the numerator. And then we're going to divide it by the denominator, which is 2 times B minus 3 times A squared. And then we're going to close the denominator. So remember, these are the ones that you add into the problem. I'm writing them extra large, but they're the same size on your calculator. So, A equals -2, so this is a -2 right here, and also back here. Oh my goodness. Come on, pen. There we go, -2. And then B is 3, so here we go. 3 here, and a 3 here. So getting that in my calculator, and once again hitting Math Enter Enter at the end of it, it comes out to, I think, an 11 over 6. So make sure you're either computing the numerator and denominator separately, or you're using big parentheses around the entire numerator and denominator. So here, 2 skills that we have to define variables very clearly today, and we also have to create algebraic expressions, which we call models usually. So a rental car company charges $25 per day for 30 cents per mile when you rent a mid-sized car. It says the model below represents, oh man, did that not copy over? Oh, I think we're supposed to write a model. Sorry. Write a model that represents the situation. Specifically, identify what your variables represent. So through our class, we would probably do a verbal model to get this problem started. But what do the variables represent? We need to come up with that too. So I think it would actually be easy if we start with a verbal model and just write the algebraic model underneath it. So total cost equals the, you can call it a flat fee. We've been calling it that in class. So they charge you something per day plus the cost per mile times the number of miles. Okay. So what I'm going to do is right underneath all of these things, I'm going to go ahead and write the variables or the algebraic model. And they don't really tell us what to use for variables, so I can use whatever I want. So total cost, I'm going to go with T equals flat fee, which is 25, plus 30 cents per mile, times the number of miles. Let's go ahead and use an M for the number of miles. So this would be a great model right here. And when it says what do your variables represent, you know, total cost for T, the flat fee or flat daily fee for 25, cost per mile, and number of miles. Notice the very specific number of miles. You can't just say like M represents miles, because that's not specific enough. So a very similar question here. A makeup artist charges $45 for a sitting fee and $15 per hour for each session. Create an algebraic model where C is the total cost and it's a single session for H number of hours. So very similar question, guys. $45 for the sitting, one charge, and then $15 times how many hours you are in the chair. Okay, I like this question. Your team is setting up a computer program for a burger chain at the store. You make a single donation of $3, and the burgers cost 99 cents, but you get 3 free burgers. So using C to represent the total cost, so we got to pay the $3 donation plus 99 cents for each burger. However, you're not paying for all the burgers, right? And they want me to use K for burgers. That's weird. So instead of just saying 99 cents times K, because you get 3 free burgers, right here it says 3 free burgers, what you have to do is say K minus 3. Because, like for instance, if you order 10 burgers, you're only going to pay for 7 of them. Okay. And that's the end of the problem. It doesn't say to evaluate. Similar question here. A gift shop advertises that we're going to engrave any gift for 8 cents per letter. There's 5 letters are free, and you're going to buy a desk plate for $35. So total cost is you buying the desk plate, and then you're going to pay 8 cents per letter. However, You're not going to pay for every single letter, right? You get 5 letters for free. So just like the burger question up here, this time it's going to be x minus 5. So then it says, take your model and figure out how much you're going to charge. Oops. No, it doesn't. I lied. I thought there was a follow-up question. There's not. All right, so we're done on that question. Moving on. Oh man, solving equations. So some of them are pretty basic and some of them are more elaborate. So here, a pretty basic one, distribute the 8. So 8x minus 24 equals 2x minus 5. And then we're going to solve for x. We're going to subtract 2x. And you know what, at the same time, let's go ahead and add the 24 so that way they're on opposite sides. Remember, constants on one side, variables on the opposite side. So we have a 6x equals 19. Dividing both sides by 6, you get x equals 19 over 6. Leave it as a fraction. Those are my best answers. Here on 7b, it's still a multi-step equation. You still have some distribution. Leave the 4 for a minute, but we're going to distribute that 5. So that's what, a 5x minus 5 equals x minus 9. Got some like terms that we need to collect over here, so this becomes what, 5x minus 1 equals x minus 9. All right, here we go. So let's bring the x's to one side. I'm going to run out of room. I wrote way too big. I'm going to add 1. Okay, my work is going to magically land up here. Here we go. So what do we have? I have 4x. Those are gone. Equals negative 8. So then last step, dividing both sides by 4. And I found out that x equals negative 2. Okay. Some more distribution. So these questions, they're not hard for you guys. You're very talented at equation solving. You just got to watch your tiny mistakes. You know, I'm one to talk. I think I make like 10 mistakes a day. But here we go. Let's try. Negative 4x. This become a plus 8. And then 20 plus 15x. All right. So we're going to move everything to one side. Let's go ahead and I'm going to add the 4x over to the right. That'll keep x's positive. While we're at it, let's go ahead and subtract the 20. So x is on one side, variables on one side, constants on the other. We end up with, what do we have here? Negative 12 equals 19x. And then be careful on your upside down division here. Sometimes if we're not careful, we divide this backwards, and that's a big mistake. So x equals negative 12 over 19. It's a great answer. Leave it like that. All right. Most common mistakes in equation solving are, you know, comparatively speaking, they look like really small mistakes, but because this is definitely not a new skill for you guys, we have to be so accurate that we don't make them anymore. All right, the 8 stays where it's at, but we are going to distribute the negative 3 here and here. So this becomes a negative 12x plus 15 equals, okay, keep distributing. This is a 8. Come on, pen. All right, 8 plus 6x, and then there's still a plus 1. So negative 12x is just staying where it's at, but we do need to combine the positive 8 and the positive 15, so that's a positive 23. And then combining our 8 and 1 over here, we still have a 6x, but now it's plus a 9. So we're going to want to bring all the x's to one side. Most of you would be adding this 12x. And then, you know what, why don't we go ahead and subtract the 9 while we're at it. There we go. So we are left with, what would that be, 14 equals 18x. All right, careful on this one because this does reduce. So remember, when you divide, hit Math Enter on your calculator, and it'll give you the best answer possible. So if you divide each side by 18, you find out that x equals, what, 7 over 9? That's the answer I want to see. All right. Apologies if I've made any mistakes. I kept blabbing about all the mistakes you guys are making. Well, it'd be ironic if I made some. All right, let's cross multiply this proportion. So remember, you are cross multiplying, which means you're going to distribute all the way through. So 6 times x plus 7 has to equal 3 times x minus 2. So let's take care of some distribution. You can do that in one step. We just find that sometimes kids on a test, they're real stressed out. Doing that in one step is not always a great idea. So that'd be a 3x minus 6. All right, now we're going to solve. Bring all your x's, your variables to one side. Bring your constants to the opposite side. So most of you would subtract 3x to the left, which means your constant, negative 42. We're subtracting 42 to the right. All right, 3x gone equals, oh boy, negative 48. And then dividing both sides by 3. I think this comes out pretty nice, actually. I think it's x equals negative 16. And then this next one, a lot of kids try to multiply by 5 everywhere, and they don't end up doing this right. So we decided in class it would be a lot smoother if we all just moved this 9 over first. If we subtracted 9, and then we have essentially a proportion. It just created less issues for you in class, is what I recall. So 3x plus 1 over 5 equals negative 7. If you want to think of it as negative 7 over 1, then you can see the direct proportion. So now when you cross multiply, 3x plus 1 times 1 is just 3x plus 1 equals 7. Negative 7 times 5 is negative 35. And we have it from here. We're going to subtract 1. So you have 3x equals negative 36. Dividing both sides by 3. You get, what is that, negative 12? I wish I had my friends with me here to give me my answers. Apologies if that's wrong. Okay, moving on. Oh, these questions. So we decided we hated fractions, but you know what? It wasn't a big deal because we are going to use our new favorite technique. And you must use this technique, guys, of finding the LCM for 5, 2, 4, and 10. So 5 and 2 and 10 would be an LCM, but this 4 really kind of messes that up. So you got to go bigger than 10. So what if we did a 20? And sometimes kids say, oh, Mrs. Abruzzo, I used a 40. Well, that's okay. What you found was a common multiple. It's just not the smallest multiple. That's all. So let's distribute this 20. And as you type 20 times each of these fractions, you type 20 times 2 divided by 5. That's how you type that on the calculator. So what does that become? That's an 8x minus 30 equals, let's see, 35x minus 6. And now we solve. So I'm going to bring all my x's to the right this time, which means I'm going to bring my constants to the left. I'm going to add 6. So the name of the game here when you're solving these equations for us, you go slow and you show your work. That's how you get through these without having any mistakes. This is usually where I make a mistake out of sheer irony. All right, like right now, okay, that was that 27? Man, I wish I had some kids here so that way they could tell me if I'm wrong. All right, divide both sides by 27. Now please, math enter this answer because that one does reduce. They're both divisible by 3, aren't they? So what is that, negative 8 over 9? All right, one more of those. Big parentheses around the whole thing. And I see my denominators are a 3, 2, and a 5 this time. Technically, there's a 1 right here as well. So 3 and 2, that'd be a 6, but then the 5 kind of messes it up. So what if we did a 30? That would work. So let's distribute that 30 into every single term. Now be careful. Everything is a fraction. So don't just think like, oh, the things that look like fractions. Well, the 2x is still a term. You need to multiply him as well. Okay, new equation. Let's see, that would be a 70x when I type that part. So 30 times 7 over 3 is what you type. Minus, let's see, that's 45, equals 60x. And then, what's the last one here? Let's see, minus 6. Okay, and we're solving. So I'm going to bring x's to the left, which means my constants are going to go to the right. So we have 10x equals, oh boy, let's see, was that 39? Dividing both sides by 10. And I'm just going to leave it as x equals 39 over 10, which is the reduced fraction answer. All right, almost there. We have one more skill, which is that isolating variables business. So this is the stuff where we ask you to get a highlighter out and lock down the variable you want. So like here, I'm trying to lock down the, oops, I kind of missed one, the b, but equation rules still apply. So if you think about, I'm going to isolate the b, the first thing I'd do is I'd subtract the 4 over. So let's do that. So if we subtract 4 from both sides, the difference is instead of simplifying this side over here, you're just going to write down what you see. So b times q, now it equals 7p minus 4. And then we're going to have one more step. Remember, we're trying to solve for b. So if we divide by q everywhere, we're going to be good. So I'm kind of running out of room, but somewhere I'd write down b equals 7p minus 4 over q. Alright, similarly, right here. There's a smaller one. Trying to solve for a. So, first thing I'd do is I would subtract this term right here over. So I'm going to subtract bt from both sides. But again, I can't simplify that, so I'm just going to write down the algebra. So I have a times q equals 5 minus bt. And then almost home free, I'm just going to solve for a by dividing by q. Everywhere. So these cancel, and I end up with, I'm running out of room, a equals 5 minus b times t, all of it over q. So your job is not to clean this up, your job is to isolate one variable, and once you have that done, you are done. Don't do any more work. Alright, this next one, I'm trying to solve for b, and he is kind of stuck inside of a proportion. So what I'm going to need you to do is think about, okay, I need to undo a couple of things here. I need to undo the multiply by 4, subtract 7, I need to undo the divide by 3. The first thing you have to worry about is undoing the divide by 3. So wouldn't we do that by multiplying by 3 on both sides? So what do we have? We have 3 times t. And then here the 3's would cancel. So they're gone. And you still have 4b minus 7. So keep your eye on the prize. We're trying to solve for b. So this guy's locked down. And our next step in this equation to solve for b, I'd add the 7.
Mr. Newmeyer, please come to the counseling office.
So we have 3t plus 7 equals 4b. And then I just have one more step and we're home free. We're going to divide up both sides by 4, if my pen will work. Okay, here we go. So divide by 4, and you don't have to clean this up, just divide by 4. So somewhere on my paper I need to write down b equals 3t plus 7, all of it over 4. Man, I should be bubbling in these answers or something. These are messy. So something I learned today is I didn't give you guys enough space. I'm sorry. Alright, this next one, solving for t. So similar question to the last one. I'm going to start by getting rid of the divide by 2. So I'm actually going to multiply by 2 on both sides. So over here on the left, we have a 2a. Come on, buddy. And then over here on the right, the 2's cancel, and you get 3t plus 5. So solving for t, most of us would start by subtracting 5. I can't simplify this side, so I'm just going to write 2a minus 5. And then we're almost home free here, guys. You just got to divide by 3. And I'm completely out of room. So can I cheat and say t equals 2a minus 5 all over 3? Alright, one more set of problems and then we're good. Oh, I lied. 2 more sets of problems and then we're good. These are the tricky ones where they're not grouped together at all. So the first thing I'm going to need you to do is move some terms around. Everything with a b, bring it to the left side. So I'm going to subtract this 2b over here. And then anything that's not a b, move it to the right. So I'm going to subtract this 10 over here. And this is where it gets kind of messy. Some things combine, some things don't. So 6b minus 2b, that is a 4b. You can combine those. And then there's nothing else over here. These are gone, and you have 7y minus 10. Those do not combine, so you just write it like that. So man, we are right there. We just got to divide both sides by 4. Again, I'm going to kind of cheat. The 4's cancel, and you end up with b equals 7y minus 10 over 4. I don't like when you guys do that and say that's your final answer. I do want you to kind of write it off to the side, so keep that in mind. All right, next question, very similar. I'm solving for a this time, so bring anything with an a over here to the left side. So let's subtract the 3a. And anything that's not an A, move it to the right. So let's go ahead and add the 4b. There we go. So this is a case where some of it simplifies, some of it doesn't. 10a minus 3a, that's a 7a. These are gone. These 3a's canceled, and you have 8 plus 4b. You may have written that as 4b plus 8. I don't care. But I'm almost home free. I'm just going to divide both sides by a 7. And again, I'm going to cheat, but you're not going to. A equals 8 plus 4b, all of it over 7. And then these are, in my opinion, the most challenging questions. The same idea, though, as the previous questions. There's multiple a's, so I can't really highlight them. But if I grouped them on the same side, we could do a cool technique. So I'm going to move all the a's this time to the right side. So I'm going to subtract 4a from both sides. These are not as cool as the last questions, though, because it says b equals am minus 4a. These are not like terms. So I have to just write down what I just read to you. Am minus 4a. But I think we're still in trouble because since these are not like terms, I can't just highlight the single a, so we have to use that technique where you factor out the a. So think about what would be left here if you factored out an a from here and from here. I'd still have an m minus 4. So remember, factoring out is like undistributing. A lot of you call it undistributing, which is cute, and I like it. And then finally, a is locked down. You need to divide this m minus 4 over. There we go. So the m minus 4s are going to cancel on the right side, and you're left with just a. So somewhere in your work, you need to jot down a equals b divided by the quantity m minus 4. I kind of like those questions. I don't know. I like that technique. I think it's neat. All right, this question is similar where you got to group all the m's to one side. So I'm going to, well, I got to move a couple things. I'm going to subtract the mt over here. And then anything that's not an m needs to move to the right. So I'm going to subtract the 4a. Ooh, that's getting messy. Sorry about that. Okay, bit of a problem though. These are gone. These are gone. 5m minus mt. Not like terms. So you just write down what I just said. 7 minus 4a. Also not like terms. So you just write down what I just said. Okay, keep your eye on the prize though, guys. We are trying to solve for m. There are too many m's right here. So we have, now that they're collected together, you're going to factor the m out. And when you take an m out of here and here, you're still left with 5 minus t. Alright, I know it feels like an age since we started this problem, but we're almost there. You just got to divide by 5 minus t on both sides. And then you should see some cancellation right here, and voila, you have m isolated. So m equals, just write it down, 7 minus 4a over the quantity 5 minus t. I kind of like those manipulation questions because you're not actually solving anything, so you're not computing anything, which means you just got to move terms around and then you're good. All right, good luck on your summative, everybody.